This is the PWM rectifier tenor setup. So in this total 3 units are there. One is a power supply, another is a PWM rectifier unit, another is a load unit. So let us first understand the connection diagram of our setup. So to run this setup, first you have to give the 400 volt supply. So that is given from this 3-phase node. So here 3-phase 400 volt 50 hertz connection are given using this MCB. So that is coming here. Then one switch is there. So this switch is off currently. So here power is cut off. Then one step down transformer is there, which is step downing the voltage 400 volt line to line to 110 line to line voltage. That 110 line to line voltage come here from this power supply unit. So this power supply unit can be turned on using this switch. So this is the power supply unit. Now this 3-phase from the power supply unit, that is 110 volt, that should be given to here. So it is given to our main unit, that is a 3-phase PWM rectifier unit. So this 3-phase are given at this node. So here another node is there where this PWM rectifier are generating a DC voltage, where we should connect the load unit, that is this unit. In this load unit there are the total 4 loads are connected. One is a 200 watt bulb that is connected directly at DC link without any switching arrangement. Another 300 volt bulbs are there that can be turned on and off using this switching arrangement. Now to observe the DC voltage, one should connect one voltmeter at DC bus. So we have connected one voltmeter. So now if we come to this screen, so in this screen when this switch is off, so this switch, let us see this switch. So when this switch is off, at that time it will be in the waiting mode, because right now it is suggesting that there is voltage less than 20 volt. So phase voltage is 0, which is less than 20 volt. So it should be greater than 20 volt to start this connection. So let us turn on this. So if we turn on this, after that you can see that right now it is started, means it has started working. So now here still PWM rectifier operation is not started, all switch are off, hence the diode is conducting, and here you can see some quantities you are observing. So currently in this quantity DAC1, DAC2, so this is the VDC star, that is a reference DC voltage. Actual DC voltage whatever it is coming, IQ, ID, DAC1, DAC2, that values are observed here. So now here some key arrangements are there. So center key is to turn on and turn off the operation of this PWM rectifier. Up key is to change the quantity which we are going to observe over the DAC channel. So here 2 DAC channels are there. So that can be connected to oscilloscope. So we have also connected this 2 channel over oscilloscope. So some quantities currently are visible in the oscilloscope. Later we will observe this. So now these quantities can be changed. So for DAC1, if you wanted to change the quantity to be observed, so you can press this key. So the number, you can see number here, it will be there 1, instead of 1 it will become 2. So quantity over the DAC1 will change, and quantity over DAC2 if you wanted to change, it will be changed using this key, down key. So you can see it become 5, so that can be changed. So this for increment of DAC1, this for increment of DAC2. Now if someone wanted to change the VDC reference, so VDC reference can be changed using this arrow. So you can decrease the VDC using this arrow. You can using this you can increase the VDC star. You can see if I press once, you can see here now VDC star will increase to 185. If I press again, it become 190. If I reduce 185, so VDC reference you can change using this 2 key. So here deck you can observe, and this is all about the connection and different part of this circuit. So here another power switch is given, that is to turn off this unit, control unit. So to turn on this control unit, you should turn on and turn off this. Now let us see the control system implemented in this setup. So here you can see this is the control system which we have implemented in this setup. So here what we are doing is 3 grid voltages that we are sensing. Using that grid voltages, we are generating one grid angle. So we are creating one grid angle using some PLL algorithm which is implemented inside. So this theta G you can observe here. So you can see voltage and grid angle. So now this is taken out from the DAC channel. Now this theta is given to ABC to DQ transformation of the current sense. So 3 current are sensed that are transformed in the rotating reference frame, using rotating reference frame, where ID and IQ component of the current you will have. Then here in this control, one outer loop will be there where the DC link voltage sensing is required. So one DC link voltage is sensed and reference DC link voltage are compared. With that, it will give an error given to the PI controller. It will give the ID reference. That ID reference is compared with actual ID. It will again generate one error that will be compensated using some PI controller, and it will generate the VD star component. And similarly, IQ we wanted to keep 0 because we wanted a UPF operation, only active power operation of this unit. So IQ we are keeping 0. It is compared with the actual value. Again the error is giving for the compensation, and VQ star are generated. Now VD star and VQ star are given to the DQ to ABC transformation. Again we will have ABC or alpha beta component that will be given to the space vector modulation. Here to run this switch is space vector modulation technique is implemented, and it will generate the pulses. That pulses is given to the switch. So over this control system, many alternating quantities are there like VA, V alpha beta, VABC, IABC, I alpha beta. Intermediate quantities are there, as well as many DC quantities are there like ID, IQ, VDC, that are the DC quantity. So whatever DC quantities are there like ID, IQ, that is shown here. You can see IQ is 0, ID is showing some value. VDC star and actual VDC are kept here. Okay, so over display you can see the DC values. Now for alternating quantities, we have arranged one mapping system over the DAC, where if DAC having a number 1, then you can see VA from that channel. If DAC is having number 4, you can see, so theta you can see. So for DAC 2 you can see here, for DAC 2 4 number is there, DAC 1 number is there. So VA and theta that you can observe over the screen. So here you are able to observe this here. So now according to this you can see any intermediate AC quantities over the DAC, as well as intermediate DC quantity you can observe over the screen. So this was all about the setup, connection, control system implemented over this setup. In the next video we will see the implementation and the working of this setup. Thank you.